Alright, but before you do that, let's all have a quick conversation about some things that I'm noticing. Sorry, I'm taking a second to put y'all's pictures into the slides. I know that's really fun to see how we do that, or to have your stuff up there. So, okay, so this I believe was group 4. If y'all could pause for me really quickly. 3, 2, 1, eyes up. Kelsey, that goes for you. Thank you. Okay,
hey,
so
that's mine.
I know. So let's have a quick conversation on this. So how many squares will be needed to create the size 100 logo? So I'm going to start with Corell. Corell actually had a really good idea on this one, where he said, you know what, Mr. King? I'm starting with 7, right? And then you realize overall I'm just adding 5 every time, right? So if I'm starting at the first size, I'm trying to get up to the 100th, how many times am I adding that 5? 99 times, right? So 7 plus 5 repeatedly for 99 times. You got 502 squares, right? That worked pretty well? Did you have to create an equation or a table or anything like that to represent that idea? That's good logic, right? I like it. But let's start to formalize some more things. So Kelsey noticed something a little bit different, a little bit of prodding from me. Kelsey, you started to notice pretty early that, hey, in the middle, the number of squares is the same as the size number, right? Is that a true statement?
Yeah.
So when I get to the 100th size, I'm going to have how many squares in the middle?
100.
100. We want to notice and look for patterns also, and so I would highly suggest that you start to circle this to note this to yourself. Devin, this would help if you pick up the pencil and take some notes for you. Does that 2 show up anywhere else, Kelsey?
Yes.
Where?
It does. Top left. Top right.
Top right?
Top. I mean bottom left and bottom right.
Hey, so how many 2's are right there?
4,
5 of them. Huh. How about how many 3's are here?
5.
Huh. How would we repeatedly add those 5 3's?
Say what?
How would we repeatedly add those 5 3's?
3 times 5.
3 times 5, multiplication, right? How many 4's are here?
5.
5. And then notice every single time there's how many extra?
2.
2. So Kelsey used that information. She said, you know what, Mr. Kinney? I feel like that means I'm going to have 100 in the middle, 100 in the top left, 100 in the top right, 100 in the bottom left, 100 in the bottom right. So that's how many total?
500.
500 plus an extra 2.
Oh gee, that's this one.
Does that work? Does that give us the same answer, 502, that all the rest of us got?
Yep.
Heck yeah. Now, I want to go a little bit beyond this, though, because y'all use just logic and pictorial representations to make sense out of this, and that's great, but let's go a little bit more formally with it. So Shelby, you started to look at this table here, right? And so I don't know if you can tell, but she said X, her size, which I really like the idea that you defined your variables there. And then Y, the number of blocks. So when the size was 1, blocks was 7, 2, 12, 3, 17, 4, 22? Sorry, it's hard for me to see. 5, 27. And you have a simple note out here of plus 5. What were you noticing there? You're repeatedly adding 5 blocks, right? And Corell, that's kind of the same idea you noted, wasn't it?
Me too.
How did you, and yes, you too. What did you use that information for, though? Why was it important that you were repeatedly adding 5 blocks?
That's your slope.
That's your slope.
Oh yeah, so I'll write that down.
Wait, when do we have slope? What type of function is that?
That's a linear.
Linear, right? We want to recognize, and Peyton, you eventually got there as well. You started out with a little bit different, but we want to recognize that it is in fact linear because we have an additive rate of change. Now, one thing I want to slow down, I do want to point out about slope. How do we calculate slope?
Rise, run, divide by run.
Thank you. Be careful of that language. Rise divided by run. That plus 5 there, is that both my rise and my run?
No, it's not. It's not.
Which one is it?
It's 5 divided by 1.
Okay. We need to recognize that my dependent variable, my y, is rising 5. Divided by how much am I running?
1.
Which, as long as you're going by 1, you can just look at that plus 5. But you need to be careful because if that's not changing by 1s on the x, that could mess up your slope. So my slope is 5. And so what'd you do from there? Used
Point slope.
point slope using this first point, right? So point slope is m times x minus x1 plus y1. So the slope was 5, the x1 was 1, the y1 was 7. Once you got that, what'd you do right here, Shelby? You and Layla did this.
I substituted 100 in for x.
You substituted 100 in for x. Now I want to point this out because this is important. You substitute 100 in for x, and honestly, if I was just doing this right here, I would just substitute it into a calculator. No, plug it into a calculator. But, Kirill, I want you to notice something. What's 100 minus 1? What's 100 minus 1?
I know.
Hey, Kirill, isn't that the same exact expression you got?
Oh my gosh, yes it is. Wow.
That's a huge connection, isn't it?
You did it faster.
But then you had to make another model afterwards. And yes, he did it faster, but we do want to be looking for those equations of a line because that can help us in the future. Now, from there, I do want to make a couple of quick notes. Namely, I want to point out, you used point slope, right? Why didn't you use slope intercept?
We didn't have the y-intercept.
You didn't have the y-intercept, but...
You could have found it.
There we go. I do want you to think about it. Hey, I could have found it, because if this is 1, 7, I'm adding 5 every time, it's 0, 2.
Actually, yeah.
Right?
Too lazy.
Hey, wait. Let's go back really quickly. You did 100 times 5 and then plus what?
2. Oh my gosh.
They kind of connect, don't they?
Yeah.
Notice these 100, you see how these things are changing right here?
Yeah.
That's your x. And how many x's do we have?
I only have
5? 5 x's. And then how many extra right here? Hey, there's your y-intercept, right? Even if you had a 0 figure, you would have those 2 there. So we want to notice those connections, point slope, slope intercept, all that fun stuff. But again, honestly, overall, writing an equation will help you move forward in figuring things out. I do want to show you this. This is my graphing table. Does anyone know where I created this?
You used Desmos.
The Desmos. Man, everyone's got that all day today. I'm impressed. Yeah, I used Desmos. I created a table here. Notice using Desmos, I was able to actually really easily get that y-intercept. And graphically, you can tell very quickly it's what?
It's a line.
It's a line, okay? It is, well, linear.
Yes.
Because I will point out, is it actually a line?
No.
No.
Because it's not continuous right now.
Yeah, sure.
So that is an important question. Should I continue between the points or should I leave it discrete?
No. You should leave it discrete.
Why is it discrete?
Yes, I said so. Because
You're right. You're the author of all mathematics. You got it. We don't care about definitions.
I'm just kidding.
Because there's nothing in between those points.
I was going to say that. Nothing in between works.
You're just adding 5 every time, or there is stuff in between.
I mean,
Yeah.
you're repeatedly adding that number over a set period. You are not add 1 here, add 1 here, add 1 here.
Oh, yeah.
No, it's 5 at a time.
It's 5 at a time, so it's jumping from one to another. I really like what Shelby said with it. Can you have half a block?
No, you can't.
No. Can you have half of a size?
No.
So can I have stuff in between?
No.
No. So it would need to be
Discrete.
discrete. There we go.
Yeah.
I know it's been a minute since we talked about those ideas, but yeah.
Well, there is a possibility you make it with a 3D printer. In that case, you have to have a block.
Concrete.
But you cannot have half of a figure.
They're so difficult.
You either have that next eye or you don't. Okay, so Marco decides to experiment with making his logo blockier so that it looks stronger. I'll be honest, I like this way more.
Is blockier a word?
Yeah.
Oh.
You're blockier. I really have no idea. I'm making that up. I'll look it up when y'all start to work again, so just a few minutes. But assuming that Marco continues with the pattern as it has begun, draw the next figure, size 4, and find the number of blocks in the figure. So work on that. There should be colored pencils or markers on your desk that you can use to draw it out. Once you get number 3 done, start to move on to number 4, thinking through those patterns. All right, I'll look up blocking while y'all work for the next few minutes.
Are you really trying to look that up?
Yeah. Y'all asked. I'll look it up for you.
Yeah.
Is it?
Yeah.
I thought so. I was like, I'm pretty sure it's a word. It literally just means to look more, or to be more like a block.
Heavily built
Funner is a
stocky,
word.
Yeah.
marked by blocks.
Funner is the word.
Funner is not a word. Let's get to work on our math. Their face is done already. Boom, got him. I'm coming over to see what you got, Krill.
Alright, look it. So, 1, 2, 3, 1, 2, 1. So 4 is gonna be 4. 1, 2. And then it's by 3, and by 2, so it's gonna be by 4. 4, 4, 4. Yes, that's 4. Really, are we gonna color?
I was going to just use a color to outline it. What you got, Krill? Huh?
So the fourth
They're done. I
size
don't see
is
done.
112.
What is it?
The
I
fourth
don't
size
know
is
how many
112
stories of what.
because there's
Okay, so this one has
48,
I got a question.
48,
I don't have an answer.
and then 16 is there.
I don't know how this is.
Are you adding 15 every time and then adding
Little blocks.
5? So this is part of the middle and then adding 15. I'm talking about.
I mean, let's think about this. How could you figure out what the pattern might be?
You have one row and then the other row.
Yeah, but this
Are
one,
you
look.
talking row, or are you talking about the differences?
Something like that.
Yeah, but look, this one, and then this one you added 3 to.
Notice what Kelsey was talking about though, which I would go a little bit beyond that. Kelsey, look,
What?
be formal with it, make your tabular representation, right? We have our figure size and we have our number of blocks. With the first figure, we have 7 blocks. With the second figure, you already noted that we had 28. And for the third, it was 63.
Wait,
So right here, you're adding 21 and then you're adding 35. But here's the thing, we don't have enough information right now to know what rate of change it is because we only have those 2.
Yeah.
You're assuming though that it's what type of, is quadratic. Well, isn't that why we're doing number 3 to figure out what size 4 would be so we know what the next piece of the puzzle is?
How are we going to figure out what size 4 is?
Well, Kelsey noticed here that, hey, right here, it's 3 by 3, so then you did 4 by 4.
Yeah, sure I did.
So like right here, did you notice that this is a 2 by 2? Do you see that 2 by 2 anywhere else?
2 by something.
But I asked,
2 by 2 right here. Oh my gosh! Oh my god, we did it again. Oh my gosh. So that means it's a 4, a 4, and a 4, and a 4, and a 4, and a 4.
what do you want?
I don't get it.
Try to re-explain.
Okay, so
Oh, I see.
2, 2, 7, 4, 4, and 4.
Well, not 4, 4, 4, that's a 2 by 2.
I mean a 4 by 4 and a 4 by 4.
Notice here, does that pattern hold that it's a 3 by 3? And then a 3 by 3?
Oh my gosh!
So how you going to know how many you add on? It's not good.
Well, okay, let's look again. Look
I
at the
get the
size.
blocks.
Notice you said it's a 2 by 2. What size is this?
Size 3.
So this was a size 3 by 3 and it's a size.
3, so I add this.
So if it's a size 4, it's going to be a 4 by. Well, notice it's always the top of the eye, the bottom of the eye, and the middle.
So I just add a row on each of 3. One more row.
Well, she's pointing out that it's a 3 by 3.
Yeah, I'm trying to just add a
You're
row.
not listening. Look, 3 by 3, 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 and 3 by 3.
Mhm.
Before, it was a 2 by 2, which, there was a 2 by 2, 2 by 2,
apparently I did something.
2 by 2, 2 by 2, 2 by 2. So for the next one, each of those is going to be a what size? Okay, so look what she's doing. She's just doing a 4 by 4.
Look at I'm so smart.
Isn't that what you said it was going to be? I'm going to come back. We got to wrap up so I can show you your homework, but let me make sure you understand that after class. All right. We'll pick back up with this tomorrow, and then we'll do a full wrap up of this lesson tomorrow, comparing these different ideas. But have we started modeling with mathematics?
No.
Looking for those patterns?
Yes.
100%, right? Are we looking for and expressing some regularity in our repeated reasoning?
Yes.
We are looking for patterns to think about. Making tables, graphs, and algebraic representations? Yes, no, maybe so?
Yeah.
So, a lot of us have already, or we all realize that the first one is linear, Have any of us realized what type of function the second one might be?
Quadratic.
Quadratic, because we are comparing linear and quadratic, so we'll look at that more heavily tomorrow. Here's your homework, 6.2 ready, numbers 2 through 4. Set numbers 10 and 12, just those 5. And I want to see that you at least attempted these. We'll talk about them. We'll have an accuracy check tomorrow night.
I already figured out four.
Huh?
Figured four out.
Let me see.
Okay, so you know how this starts at 3 o'clock, right?
Yeah.
That goes to 6, add a second row. 9, add a third row. 12, add a fourth row.
Oh.
Okay, so this is 1, 2,
Yeah.
add a second row. 3, add a third row. 4, add a fourth row.